Welcome, friends. I'm new. I've always been fascinated by games where you can rewind time and use mechanics to control time. I wanted to see what it would take to build that type of capability in Unreal, so I built a prototype. Today, I'm going to show you everything that I've built. I'll show you how I've built it, and I'll also at the end show you where you can get my project if you either want to play with the mechanics on your PC, or if you want to take my code and use it in a project of your own. To start with, I'm going to take you through a handful of examples. We have a trench that is preventing us from getting to the workshop on the other side. Our player falls in, can't make the jump. Thankfully, we can rewind time for the player to get the player back up where they started. Now, let's say we create a bridge here. Unfortunately, the bridge is falling. Thankfully, we can rewind time for objects in the game without rewinding time for our player, which allows our player to run across. We can also start to do interesting things like have the player ride up on the blocks as they rewind. And we can take a big jump at the end to get some additional height. So there might be some fun platforming things we could do. Now let's create another bridge. This bridge starts higher up in the sky, so we can't just rewind to the start and then walk across. But what we can do is let the bridge fall, freeze time, and then rewind and fast forward the bridge until we get it in exactly the position that we want for our player to be able to cross, like so. Next, we've got some moving platforms. Unfortunately, even from the very top of this platform, we can't quite make the jump that's required to be able to actually get across. So we're going to have to do something else. Well, we can ride this platform to the top, jump, freeze time, wait for the other platform to come, unfreeze time, and then our player can successfully cross into the workshop. In this example, we've got a cube falling that's smashing a pile of barrels. As before, we're able to rewind time, freeze time, and then rewind and fast forward. Something different I want to show you here is we also have the ability to change the speed that rewind happens. So here we have it going incredibly slowly. This is quarter time. This is half time. This is real time. Let's let it fall again. This is double speed. And this is 4 times speed. So on those higher speeds, the barrels restack themselves very quickly. Finally, I've built these 3 giant stacks of barrels, and I have taught my player character how to shoot these giant spheres to knock them over. I just think it looks super cool watching a bunch of different objects rewind all at the same time. I also think there's a bunch of interesting game design things we could potentially do, given that we have the ability to ride an object in motion as it rewinds through time. Let's see if I can successfully get on one of these barrels while it's moving and not get knocked off. To implement rewinding, I'm snapshotting a small amount of state about each actor as it moves through the world. This allows me to then build a local timeline for each object, which is visualized here. When I rewind and fast forward time, I simply interpolate between those snapshots to move the object back to where it was or towards where it was going in the case of a fast forward. The state that I'm tracking specifically is the object's transform, so we get its scale, rotation, and location, as well as its linear and angular velocity. That allows us to unfreeze time and have an object continue along the same path it would have traveled if we had never rewound time. You can see this with the blue barrel. When I rewind and release that rewind, it should travel roughly the same way it did the first time. I'll do that one more time. There are really only 4 important classes in my prototype. The first is the rewind component. The rewind component is responsible for building that local timeline that I just showed you. In addition to the rewind component, I have a game mode, which has some global operations and is responsible for informing all of my actors participating in rewind, whether it is time to begin a rewind or a fast forward or a time scrubbing operation. I have a rewind character, which is just a character who also knows how to do rewinding. And I have a rewindable static mesh actor, which is just a static mesh actor who knows how to do rewinding. The rewind component has a few different pieces. First, we've got 2 events. On-time manipulation started and on-time manipulation completed. Let subscribers know when we're starting a rewind, fast forward, or time scrubbing operation and when that operation completes. In the project, I'm using that right now to apply that green tint to objects while time is being rewound. The actual timeline is stored in a ring buffer, and I'll talk more about ring buffers in a minute, But transform and velocity snapshots is keeping track of an actor's transform and velocity. I've got another ring buffer for movement velocity and movement modes, and that is only used when we are rewinding a player character. There's basically a little bit of additional state that we need to keep track of in order to do things like animate the character during a rewind. The rewind component is also going to grab a reference to its owner's root component, movement component, and skeletal mesh if it has one, and it needs those references in order to apply state while a time manipulation operation is happening. There are a few public member functions. There's is rewinding, is fast forwarding, and is time scrubbing. Those all sort of do what you would expect. Tick component is driving all of the actual work. If we are not rewinding, fast forward, or time scrubbing, tick component is going to call record snapshot, which is going to write down state required to build that timeline. If we are rewinding or fast forwarding, tick component is going to call play snapshots, which will play back and forth on that timeline. And if we are time scrubbing, then tick component will call pause time, which is going to freeze time and do a little bit of clever interpolation if we already had a rewind or a fast forward in progress. For completeness, I did show what is in those different types of snapshots here. The transform and velocity snapshot is going to keep track of a time value, the transform, the linear velocity, and then the angular velocity. The movement velocity and mode snapshot is going to also keep track of a timestamp. It's going to track that movement velocity as well as the movement mode. On the game mode, I'm exposing a few member functions that allow us to start and stop those global time manipulation operations. So we have start global rewind, stop global rewind, start global fast forward, stop global fast forward, and toggle time scrub, which will turn time freezing on or off. And then I have a started and completed event for each of those operations. All of the different actors that have a rewind component have their rewind component bind up to these events on the game mode. And then when I start a global rewind, for example, they'll all get notified that a global rewind started and then start applying snapshots. The rewind character is just the third-person player character, except it has a rewind component. And I've also added a little bit of code to do input binding for a variety of different hotkeys. But when you press one of those hotkeys, it then turns around and calls those functions on the game mode that we just talked about. So when I press R to start a global rewind, it calls start global rewind on the game mode. The game mode is then going to notify every rewind component in the world that we are rewinding. When you let go of the R key, the player character is going to call stop global rewind over on the rewind game mode, which will then let every rewind component in the world know that we're no longer rewinding via the on global rewind completed event. Rewindable static mesh actor is just a normal static mesh actor, except it has that rewind component, which of course then allows it to do rewinding as we just described. Let's look at the code. In the rewind component's begin play method, we're going to wire up everything that we need to take snapshots and to do time manipulation operations. We're going to attempt to grab the root component, which is going to be a primitive component from our owner. If we are attached to a character and if we've been told to keep track of movement data, we're going to try and get the owner's movement component. We're going to try and get the owner's skeletal mesh. Then we're going to go over to the game mode and we're going to bind to those 6 events so that we know when a global rewind, fast forward, or time scrub operation starts. Finally, we are going to allocate the space that we need for all of our snapshots in our ring buffers based on how long we've been configured to keep data for. In the case of my project, I currently have this configured to 120 seconds. I could go longer. This is mostly just a memory consideration. To initialize the ring buffers, I am figuring out the max number of snapshots that we need to keep track of, and then I am taking the configured maximum rewind settings and dividing that by a configurable snapshot frequency. I played with a bunch of different values. Right now, I've got snapshots configured to take a capture every 33 milliseconds. I found that 30 times per second gave me enough granularity that everything looked smooth and looked good, but didn't consume an excessive amount of memory. I then do some checking just to make sure I'm not shooting myself in the foot. If we're not being asked to keep track of movement, then I am ensuring that I am using less than 1 MB of memory per actor. In the case of the player character, I'm using up to 3 MB. We allocate space in our ring buffers up front, so we don't have to do any allocations once we are actually ticking. If we are only keeping track of transform and velocity, then we just allocate that buffer. If we are also being told to keep track of movement, then we allocate the second ring buffer. Then, when we actually start playing, we come into tick component every single frame. And this is where the vast majority of the work is happening. If we are currently rewinding, then we are going to play snapshots in reverse. If we're currently fast forwarding, we're going to play snapshots forward, assuming we have any. If we're time scrubbing, then we're going to pause time. Otherwise, we don't currently have a time manipulation operation going on, and we are just going to record the next snapshot if applicable. We'll look at each of these in just a moment, but I do also want to call attention to debug draw snapshots. This is the piece that is drawing that timeline visualization that you saw in my editor before. This right now is not very performant. Maybe I will make it more performant in a future video. But right now, what it does is it literally just goes through every single snapshot that we're currently tracking, every single frame, and then calls draw debug point and draw debug line. So obviously, if I have a full set of 2 minutes worth of snapshots for a bunch of different actors, this is going to get really, really slow. And in fact, if you let it run, you'll see the frame rate go down over time. But you can toggle this on and off with a hotkey or with a CVAR. It's not intended to be fast yet. Okay, let's look at record snapshot first, because this is what's going to be happening most of the time we're playing. This is what's running whenever we are not doing a time manipulation operation. We are keeping track of the time since we last took a snapshot. And if we have not exceeded our configurable threshold, which in my case is 33 milliseconds, then we're going to do nothing. We're just going to bail. We don't need to take a snapshot yet. We're just going to keep accruing time until we clear that threshold. Then, once we get here, we know, hey, I actually need to take a snapshot. If our ring buffer is already at capacity, we are going to drop the oldest one. So if we're configured to take 2 minutes worth of snapshots and it's been 3 minutes, every time we come and take a snapshot, we're going to drop off the front. And this is actually why I am using a ring buffer rather than an array. The ring buffer provides us very fast removal from the front, and it's still contiguous in memory. You can pause the video and look at this in detail if you're interested, but I will show you a super quick example of how to use a ring buffer and what all it does, as well as what's going on in memory under the covers. So if we create a ring buffer and if we reserve 8 slots, we are going to have 8 slots in memory. If we add A, we get A. If we add B, we get AB. If we add C, we get ABC, and so on and so forth, up until this call to add front. When we call add front H, that's actually going to insert an H in front of A, B, C, D, and E, but it is going to do that without shifting these elements in memory. It basically does some clever math and uses 2 indices to loop around an underlying buffer, so we can both add and remove from the front or the back very quickly. So if I call add front G, we get G up front. If I call add front F, I get F up front. If we call pop front, we remove that F and we just have G, H, A, B, C, D, E. If we call pop, we remove from the back. And then if we call add twice, we add I and J to the back. So in our code here, when we're saying pop front, what we are doing is we are very quickly removing the oldest snapshot from our timeline. Then we are grabbing the transform. We are grabbing the linear velocity from the owner's root component. We are grabbing the angular velocity, and we are adding all of those to the latest index in our ring buffer. So this will be our newest snapshot. Velocity is important. I will show y'all in video a little bit later what can happen if you don't keep track of velocity. But basically, if you are only keeping track of the transform and you had an object in motion, when you stop the rewind, that object is going to restart its physics simulation where you're restarting, and you're going to have a bunch of bugs around things not moving the same way. If we are also capturing movement, Then we're going to do the same thing to our movement ring buffer. We're going to drop the oldest value if necessary. We're going to grab the movement velocity from our owner's movement component. We're going to grab the movement mode from our owner's movement component, and then we are going to add that to our ring buffer. Finally, we are going to mark, hey, time since I last captured a snapshot is now 0. We will begin accruing time again. Cool. So that is how we record snapshots. Now let's look at what happens when we want to play a snapshot back. When we are playing snapshots back, what we're basically looking for is what are the 2 closest snapshots to where we currently are in time so that we can interpolate between those 2 snapshots. So to do that, the first thing we want to do is we want to multiply the current delta time by the global rewind speed. Normally, this is just going to be 1x, but I also have hotkeys set up so that you can change it to 0.25x, 0.5x, 2x, or 4x. So basically, you can go slower or faster. We're going to add the delta time to the accrued time since we last changed our snapshots. Then, if we are rewinding, we are basically coming from our current snapshot index, and we are going backwards through the buffer until we no longer have more accrued time than the amount of time associated with that snapshot. So if I were rewinding time at 10x speed, we'd be multiplying delta time by 10x, and we might jump over multiple snapshots to find the 2 snapshots that we want to be interpolating between. Similarly, if I'm fast forwarding, instead of going backwards through our set of snapshots, we're going to be going forward through our set of snapshots. But it's the same general idea where we're basically looking at the amount of time that we've accrued. We are looking at the time associated with each snapshot. And if we have more time accrued than the time for that snapshot, then we move on to the next one. And we just keep doing that. So we're either dropping snapshots that are too far in the future to be relevant, or dropping snapshots that are too far in the past to be relevant. There is a special case, which is we might reach the end of our track, right? Like we might have rewound all the way back to our first snapshot, or we might have fast forwarded all the way to our latest snapshot. And that's what this be reached end of track variable keeps track of. If we do hit that, we're going to clamp our interpolation to the final snapshot at either end of the track. Great. So once we have figured out what snapshot we're working towards, which is now what latest snapshot index is going to be, we just interpolate and apply the snapshots back. So the way this works is for a transform in velocity, it's going to grab the previous snapshot and the next snapshot. It's then going to blend those snapshots. The way the blending works is we are just going to take the 2 transforms and call the blend function on transforms. For velocity, we are just going to do a linear interpolation. We are then going to do the exact same thing for the 2 relevant movement snapshots. To do that, we are doing a linear interpolation on the movement velocity. And for movement mode, we are just picking whichever movement mode is closer. And that is how we play back the snapshots. The last thing to show y'all is what happens when we actually pause time. Where's my tick function? Here's my tick function. So if we're not rewinding and we're not fast forwarding, but we are time scrubbing, then we are going to pause time. So to pause time, what we want to do is we want to continue the interpolation if we were previously rewinding or fast forwarding up until the point where we hit the snapshot. And then we want to just continuously reapply that snapshot while time is frozen. So we check, were we previously interpolating towards a snapshot? If so, we're just going to keep that going just like we did in play snapshots. And then if we hit the target snapshot, then we are just clamping to that snapshot and then applying that snapshot over and over and over and over. And once we get there, we're pausing the animation. That has the effect of freezing the character wherever they were. Speaking of animation, you may have noticed I am not snapshotting bone positions or a whole bunch of details around animation. All I'm snapshotting is the movement velocity and the movement mode. And that is because on my player character, when I reapply the movement velocity and the movement mode, I then am able to just run the anim graph to do animation. So I did add a little bit of logic to our animation graph. when I am grabbing references in the event graph, I'm grabbing the rewind component, and I am setting two variables, basically whether or not we are currently rewinding or fast forwarding. This is otherwise identical to the event graph in the third person template. If either of those is true, then I am setting should move so long as I have a positive ground speed. Then in the actual anim graph, I believe over in locomotion, yes, I've added an additional state called walk, run, rewind. By default in the template, it's just idle to walk and run. And the transition between walk, run, and walk, run, rewind is just whether or not is rewinding is set. Similarly, between idle and walk, run, rewind is whether should move and is rewinding is set. So a fairly simple modification to the anim graph. In this conduit, I have a blend space called walk, run, rewind. It is identical to the walk, run blend space, except in the rewind blend space is instead of playing run forward, walk forward, and in place, I have created another copy of those animations and appended rewind to them. And the only difference is the animation rate here is playing at -1. So it runs in reverse. This has the effect that when we rewind our character animates instead of simply sliding. And if we freeze time, we can freeze in different animation poses. This is not perfectly accurate. This is not necessarily the exact same pose that our character was in when time was just running forward, but it is a good enough approximation that I think it looks pretty good. I also did a little bit of work so that if I slow down time, we get an animation that looks a little bit more natural as opposed to a full run speed moonwalk. That's the vast majority of what went into this prototype. I don't have enough time to go through every single line of code here in this video, but if you're interested in additional details and all the edge cases and all of the things that I did to make it feel better, definitely check out the project in the GitHub linked below. And I'm happy to answer any questions either in the comments or in Discord. Let me know if you like this kind of video. Maybe I can do more book report style, hey, I built this things in the future. Otherwise, until next time, be kind to one another, and I hope you enjoy the blooper reel that follows of all of the various bugs that I encountered along the way. Until next time, be kind to one another. Peace.